For this example, we have 3 variables and 3 equations. We're going to use matrices, so I'm going to set up my augmented matrix by taking the coefficients of the x, y, and z in constant terms. The first thing I want to do is get a 1 in the first row, first column. Now I have 2 choices to get a 1. I can either switch 2 rows or multiply by the reciprocal. In this case, I can see a 1 that's conveniently located in row 3. So I think the easiest thing to do to get a 1 there is to switch row 1 with row 3. I could have multiplied by the reciprocal, but that would have got me fractions, and I want to avoid fractions if I can, because then I'll have fractions basically throughout the rest of the matrices. So this way I can get a 1 in the first row, first column without actually having to divide or multiply by the reciprocal and get a fraction. So step 1 is done. I have a 1 where I want it. Next, I'm looking for zeros below it. So I'm going to get a 0 where the negative 1 is, and then a 0 where the 2 is. So in order to get a 0, I'm going to multiply the opposite of negative 1, which is positive 1, times the row with a 1 in it, and the row with a 1 in it, this case is row 1, and add it back to the row that I'm manipulating, which is row 2. At the same time, I'm also going to get the 2 to be a 0. The opposite of positive 2 is negative 2, times the row with the 1 in it, which is still row 1, and add it to row 3, put it back to row 3. Now this is going to take some work, so I'm going to come off to the side of my paper. So 1 times row 1 is 1, negative 3, 2, and negative 15. Plus, right underneath it, I'm going to write row 2, and then add down. 1 minus 1 is 0. No surprise there, that's what I was hoping to have happen. Negative 3 plus 2 is negative 1, 2 plus 2 is 4, and negative 15 plus 6 is negative 9. In green, I'm going to do negative 2 times row 1 and add it to row 3. So I'm taking row 1 and multiplying by negative 2. 1 times negative 2 is negative 2. Negative 3 times 2 is positive 6. 2 times negative 2 is negative 4. And negative 15 times negative 2 is positive 30. And then I'm going to put row 3 right underneath that and add down. 0, 7, negative 5, and 40. So in my next manipulated matrix, row 1 is the only thing that is going to stay the same. And then row 2 is going to be the changed purple one, which is 0, negative 1, 4, and negative 9. And then my third row is that work that I did in green, 0, 7, negative 5, and 40. So if I go back to check my work, I have a 1 where I want it, good. I've got 2 zeros below it, excellent. So the next thing I want to do is to get a 1 in the second row, second column. Now I can't do any changing of rows here because I might mess up my 1s and my 0s for my first column, and I don't want to do that. So I'm going to have to multiply by the reciprocal. The reciprocal of negative 1 is 1 over negative 1. Multiply it by row 2 and put it back into row 2. Now, 1 over negative 1, that's really just negative 1, isn't it? So I'm basically just multiplying by negative to change the second row to become a 1. Row 1 and row 3 are going to stay the same. Make sure that when you're copying your rows, you're very careful with your positives and your negatives. 0 times negative 1 is 0. Negative 1 times negative 1 is positive 1. 4 times negative 1 is negative 4, and negative 9 times negative 1 is positive 9. Okay, so in my progress check, I have a 1 and zeros below it in my first column. I have a 1 in the second row, second column, but now I need zeros above and below it. Now to get zeros above and below, I would like to take the opposite number of negative 3, which is positive 3, multiply it by the row with the 1 in it. In this case, the row with the 1 in it for column 2 is row 2. And add it back to row 1, and that's what I'm changing row 1 into. So that's replace row 1. At the same time, I'm going to try to get the 7 to become a 0. The opposite of positive 7 is negative 7, times the row with a 1 in it, which is still row 2. Add it back to row 3, which is the row that I'm manipulating. Okay, so in purple, I'm going to use some work off to the side of my paper. 3 times row 2, so 0 times 3 is 0. 1 times 3 is 3. Negative 4 times 3 is negative 12. 9 times 3 is 27. And I'm adding row 1 to that. Row 1, which is 1, negative 3, 2, and negative 15. Add down. 0 plus 1 is 1, which doesn't change my 1 in the first column, which is good. 3 minus 3 is 0. No surprise there. That's what I was hoping to have happen. Negative 12 plus 2 is negative 10, and 27 minus 15 is positive 12. In green, I'm going to take negative 7 times row 2, so that's 0. 1 times negative 7 is negative 7. Negative 4 times negative 7 is positive 28, and 9 times negative 7 is negative 63. I'm going to put row 3 right under that. 0, 7, negative 5, and 40. And then add down. 0, 0. 28 minus 5 is 23. Negative 63 plus 40 is negative 23. So in my next matrix, I have row 2 staying the same. Row 1 is going to be replaced with that purple. 0, 1, negative 10, and 12. And then the green is going to go in my last row. 0, 0, 23, negative 23. So in my progress check, I have a 1 where I want it and 0's below. I have a 1 where I want it and 0's above and below. The next thing I'm looking for is a 1 in the third row, third column. The way I get a 1 is I multiply by the reciprocal, and the reciprocal of 23 is 1 over 23. 1 over 23 multiplied by row 3, put it into row 3. Row 1 and row 2 stay the same. Be sure to copy carefully. When I multiply by 1/23, if that's difficult for you, you can think of divide by 23. 0 divided by 23 is 0. 0 divided by 23 is 0. 23 divided by 23 is 1. Negative 23 divided by 23 is negative 1. So in my progress check, I have a 1 where I want it. I have 0's below it. I have a 1 in the second row, second column, and 0's above and below it. I have a 1 in the third row, third column. Now what I want is 0's above and below it. Okay, so when I'm trying to get a 0 where the negative 10 is, I take the opposite of negative 10, which is positive 10, multiply by the row with a 1 in it. In this case, the row with the 1 in it in column 3 is row 3. Add it back to row 1 and put it into row 1. At the same time, I'm going to manipulate row 2. The opposite of negative 4 is positive 4, times the row with the 1 in it, which is row 3, and add it back to the row manipulating, which is row 2. And I'm going to have to do this work off to the side. So 10 times row 3, 10 times 0 is 0, 10 times 0 is 0, 10 times 1 is 10, and 10 times negative 1 is negative 10. And I'm going to add that to row 1, which is 1, 0, negative 10, 12. Add down, I get a 1, a 0 in the third column, so that's not a big surprise. That's what I was hoping to have happen, and then 2. So in my next iteration, row 1 is replaced with 1, 0, 0, 2. Row 3 stays the same, 0, 0, 1, negative 1. And then in green, I'm going to work on 4 times row 3 plus row 2. So 4 times row 3 is 0 times 4 is 0, 0 times 4 is 0, 1 times 4 is 4, negative 1 times 4 is negative 4. And then I'm going to add row 2 right below that. So 0 plus 0 is 0, 0 plus 1 is 1, 4 minus 4 is 0, negative 4 plus 9 is 5. And that's going to be replaced into row 2. Notice that I have 1s down the diagonal, and I have 0s below and above all of those 1s. This is now in reduced row echelon form. If I rewrite this back into equations, the first equation is x equals 2, the second equation is 1y equals 5, and the third equation is 1z equals negative 1. This is my answer, 2, 5, negative 1. And I'm going to go ahead and leave the check to you on this problem.